Yes, we are live now. Harsh, over to you.
Oh no, wait. Uh, Welcome back, audience. For this next session, we have Harsh. So, a little bit an introduction about him. He is a cybersecurity analyst at Detox Technologies. He is also among the Buckrout top 150 researchers. He has also authored two books that are based upon hacking, the art of hacking. So, we welcome you, Harsh, to the Null virtual meet, and we are really excited to have you here. And I just want to wish you all the very best for your session, and you can now take over the mic.
Hi Shreya, thank you for the nice introduction. Hi everyone, good evening. So today we will be talking about broken cryptography and account takeovers. So broken cryptography is one of the interesting yet less traveled road in terms of the web application security or bug bounty, you can say. Even for the pen testing engagements, many people just when they say that something is encoded or something is hashed, they just stop looking at the possible ways to decode them or possible ways to basically find out what can be hidden inside them. So today we are going to discuss all about like broken cryptography and what are the possible ways to perform account takeovers. So yeah, a quick introduction about me. I am a cybersecurity analyst at Detox Technology, a Cynic Red Team member, a Leggy Bug Bounty Hunter. I have authored multiple books on hacking. I sometimes speak at the conferences and chapters. I do write blogs on Medium and some videos on Detox YouTube channel. Apart from that, I sometimes write stuff and I learn things on a regular basis to stay updated with what's going on in the industry. So a quick agenda about today is we will be first looking at the cryptography and broken cryptography 101s. We will be understanding, okay, what are the factors involved into the broken cryptography? What are the cryptographic methods, endpoints to test for broken cryptography? Then further, we will be looking at account takeovers 101. What are the possible ways to test for account takeovers? At the end, we will be looking at around like 4 to 5 case studies that revolve around the broken cryptography to account takeovers, some other methods to perform account takeovers to give you a quick understanding that how we can find something, how we can chain bugs in the real life scenario, real application, whether it's a bug bounty hunting or it's pen testing engagement. A quick tips, and at last you can ask your queries and flood it over YouTube, and the Shreya or Anant will just move it over here. Okay, so when we say broken cryptography, I just want to first give you a quick introduction, a 100-foot overview about the cryptography. Cryptography is simply a practice, a secure practice to ensure that the data or the communication happening between two or more parties is secure. So for example, user A wants to send some message, say hello to user B. Now, if he sends the message in a plain text, there is a high chance that attacker can eavesdrop the communication and read the message hello. Now, when the cryptography triggers in between, the hello will be encoded into something, say ABC123. Now attacker do not know what the string ABC123 means, right? Just giving a quick example, it's insecure. Obviously, you can try to decrypt it. Just an example for the cryptography. Now, the communication for A and B is now secure because the attacker do not know what exactly the message is being transferred between the two. Now, there are various encoding and encryption algorithms available to perform cryptography. You might have heard a lot like base64, RSA256, HS256, MD5, and there are a lot of kind of encryption and encoding algorithms available. Cryptography is usually about symmetric and asymmetric. In symmetric cryptography, we usually say that there is only one secret key or one key involved to both encrypt and decrypt, whereas in asymmetric, there are different key to encrypt and decrypt. Symmetric key cryptography is again like considered to be less secure, reason being involvement of one key only. It's widely used and a base of computer application. Like you will see cryptography almost everywhere. So taking a quick example, when you go to download some application, say you are going to download Kali Linux ISO, you will see a checksum over there, which is a hash again. So checksum are basically used to identify that is it coming from a secure source. You can download the particular ISO file and again calculate the checksum of the downloaded file, compare it with the one provided on the vendor's website. If both matches, it means that there is no tampering in between. There is nothing changed in between when you downloaded the ISO file. Okay, so this is again like, one of the application of the cryptography, checking the integrity. You might have seen cryptography in the various part of the application, like say password reset tokens, hard-coded secrets, API keys, cookies, authentication token. Quick example is the JWT token, right? So JWT token is like simply, take your payload algorithm and your signature, encode it to the base 64, and then you get your JWT token. Again, the secret part of the JWT token is something which makes it secure, and what kind of algorithm that you going to use on it. So these are the few things that we will, talk about in the broken cryptography's case. Okay, so when we say broken cryptography, it simply refers to that whenever a weak generation algorithm or a weak generation method is being used to generate a secret, it is possible for an attacker to basically crack it or get hold of the data or reverse the kind of encoding or encryption that is being used. For example, if you are using a communication method where messages are encoded in base 64, and by any means possible, if an attacker can get hold of that simple base 64 hash, he can simply go and calculate the reverse of base 64 hash. It's really like easy to calculate what base 64 data holds, right? Another example is like, if a JWT token is using HS256 algorithm, and by any means an attacker can get hold of a public key, okay, the attacker can basically use the public key to get hold of the signature, and now the attacker can regenerate the JWT token for any other user. A password reset token might be using some weak ciphers, a Caesar cipher or rotational ciphers, which are again weak, and an attacker can basically go and try to reverse them or decode them and generate password reset token for any user. So these are the few examples that where you can, understand what broken cryptography is. It's all about like using some weak generation algorithms or guessable hashes. Like there might be some short length hashes which can be brute force. So for example, an application using a 4-digit CSRF token, which you will not see, but it's like, it totally depends upon the developer that how they are implementing something. So for example, there's a 4-digit CSRF token. Now you can basically, brute force and generate a CSRF token which is just only for 4-digit for any user, and try to bypass the validation and perform an account takeover, perform a CSRF attack using that. So it's always like you have to look for every possible endpoints for broken cryptography. So these are some of the favorite endpoints that I usually ensure that I am looking properly if any kind of weak cryptography is used. The first thing is session cookies. Often the session cookies are generated by some of the well-known libraries. So for example, we are using a Laravel framework. The cookie will hint me that Laravel underscore say cookie, or if we are using say Java or JSP, then it might say that JSession ID or something. Now I can try to enumerate what kind of libraries JSP or maybe Laravel is using to generate session cookies or generate a cookie. I can try to see if I can basically use the same method to generate a cookie for the application, and try to change the cookie which I generated with the original one, and try to see if I can basically, perform some malicious activity or not. A lot of applications recently started using encoded path and parameters so that attacker do not know where the request is going, what all the parameters are going in a request. Now, if there is say, recently I was on a pen test engagement where there was a header called xcompress header, which the value was by default set as a yes. And after that request, all the request will go into some encoded data. Now, basically, if you will say x compressed equals to no, and from the next request, every request will be like, in the normal format, you will be able to see where the paths are going, where the parameters are going. Also, like you can find the cryptographic secrets in the JavaScript files often. I have found a lot of endpoints, JavaScript files where there were like, username, password encoded in MD5 hash, or maybe encoded in the base 64 hash. You can get hold of those base 64 hashes and try to decode them and see if you can get hold of the username and password in the plain text itself. Password reset link is one of the endpoint where I found my one of the best bug which I considered so far. There was a weak cryptography used, and we will discuss a case study around it, that how we can perform broken cryptography in password reset links to perform account takeovers. As I mentioned earlier, CSRF tokens length or how they are generated sometimes reveals that which kind of cryptography is in use, and you can try to again see that you can reverse the cipher or not. You can decode or try to perform brute force to see if you can generate the CSRF token, a valid CSRF token. Authenticity token, or any token for the authentication or maybe authorization such as JWT token, if they're using some weak algorithms, you can again try to. So as a pen tester, if some application is using a weak algorithm, we do report it. But as a bug bounty hunter, you have to make sure that you are going to the maximum impact and the maximum depth. You have to show the attack scenario, that if you are saying that a JWT token is using HS256, you have to actually try to generate a signature, try to create a new JWT token, forge one, and use it, and like tell them that yeah, I can forge a JWT token on behalf of any user, and I can get access to the area which I should not be able to access by any other means. Username, passwords, or that how data is being stored. You can sometimes try to fiddle across that how the username and password are being stored in the database. You can try to perform like provide some malicious string in the username and password while registration, and try to see if the database is basically once I found a bug. There was some format string vulnerability on providing some format string, like say %s or %d or something. The application was triggering like a small time denial of service attack. So you can like look for all these endpoints, that how things are handled on the back end. There might be many other endpoints depending upon the application's use case, that how developers are implementing certain features or methods into the application. So this is a quick introduction to the broken cryptography, and we will look at it again once we will dive deep into the case studies part. Okay, so let's talk about account takeovers for a while. Account takeover simply means that if, as an attacker, I can gain a persistence access to any victim's account. So basically, if I can perform any CRUD operation, create, read, update, or delete option, any of them on a victim account with a persistence access, I need not to perform an attack again and again to the victim to gain the access for any of these actions. For example, I performed an attack. Now I have a persistence or access. I can access the victim's account anytime, or like whenever I want. So this is something we call account takeovers. Account takeovers, to not confuse with, is not a vulnerability class itself. It is a result of multiple vulnerabilities chained together, or you can say it's an incubated vulnerability. It's a migrated vulnerability. It doesn't like exist at the first place. You might find an IDOR, or you might find a CSRF attack from which you were able to change email address of a valid user. Once you change the email address to your attacker controlled email, you just went to password reset and created a password reset link on which came to your email, and now you change the password, and now you have the persistence access to the victim's account. Yes, it is an account takeover, but again, it's directly doesn't mean that you did account takeover. You relied upon maybe CSRF or maybe IDOR to perform or initiate the attack first, and then using that attack's result, you perform an account takeover. So whenever you find some certain criteria of bugs like cross-site scripting or CSRF or maybe IDOR, always try to look for the ways where you can perform an account takeover. I will walk you through a few of my own findings where I was able to perform account takeover via CSRF, via XSS, via broken cryptography, and some other methods. Okay, so these are my ways to perform account takeover. We will go upon them one by one, and we will discuss that what you can basically do and what all test cases you can perform while checking them. So let's first talk about CSRF. Okay, so if an application is vulnerable to CSRF attack, basically it means that you can change certain areas of the application. My favorite endpoint to test for CSRF, where the user profile or the user's identifier, say a username or maybe an email address or some user ID, is something which I can change via CSRF. Now, assume a scenario where you can change the email ID of a user using CSRF. Now, all you have to do is to reset the password to the attacker controlled email address. And now you can get hold of the account of the victim. You now have the persistence access to the victim's account. There was a case study which we will be discussing, that how I was able to perform CSRF and client-side validation bypass to a full account takeover in a single go. Okay, so now let's talk about cross-site scripting. So cross-site scripting is a flow where, like, most of the people or pen tester, bug bounty hunters, they simply just say pop-up alert document.domain or maybe document.cookies, and that's all, right? Now, the first thing, whenever you find a cross-site scripting, go and quickly check, are the session cookies which are responsible for the session are secure and having HTTP flag only flag or not. If they are missing the secure and HTTP only flag, you can basically steal the cookies in the real time using cross-site scripting. Okay, so now if you see that there are cookies which are not having this HTTP only flag and you are having stored accesses, for example, you can basically set up a listener where whenever a person will go or interact with your accesses payload, the cookies will be transferred to a remote server. Now, using the cookies which you got on the remote server, you can you can try to log into the victim's account. Now the access is currently not persistence. You have to again look for a way to change the password or change the email address or something. And if there is a way to do something, okay, you can now basically change the email or change the password and convert your say a primary access to a persistence access. Okay, now broken cryptography can be found into the password reset links. It can be found into the JWT tokens or any kind of cookies or authentication token which are powering your authorization check, basically that what user is currently logging in. So you can always try to look for the randomness or degree of randomness into the token generated. You can use burp sequencer to do that. You need a little knowledge about the cryptography at least to understand and see. So for example, if I will see a cipher which is base 64 or a simple Caesar cipher, I will like quickly analyze it because I have a basic knowledge about cryptography. So make sure that you spend a little time understanding what all basic cryptographic methods are, like MD5, RSA, maybe SH256 or something, and some other like base 64 and some hashes like that. Now, IDORs are basically like comes under the category of your broken access controls, where you can change a particular field or change a particular data or impact the integrity of a victim user's account. If you can basically perform an IDOR during password reset, or maybe perform IDOR during changing the permission in cookies, there are several instances. One of the case study we will be discussing where I was able to perform IDOR in session cookies to perform an account takeover. Now, IDORs can be again usually seen in the user profile section where you can change the email address. Now, again, like the CSRF, once you change the email address, you can reset the password and gain the persistence access. Session hijacking is again an example where you are stealing the cookies and again chaining another vulnerability, say changing the email or changing the password. One of the example of performing session hijacking is via cross-site scripting. There might be other methods like taking a real life scenario where the application is using HTTP protocol on an insecure network. An attacker might eavesdrop, perform a man-in-the-middle attack to perform sort of session hijacking attack. This is again a very realistic scenario which might happen and sometimes happen as well. But in terms of the pen testing or bug bounty engagements, you might need to find a way such as cross-site scripting to perform session hijacking. Session fixation is an attack which often people get confused about. So session fixation, as the name suggests, the value of the session identifier before the login, after the login, and even after the 100th login will be always fixed. So for example, the application generate a session identifier called Harsh at the rate 123. Doesn't matter that how much time I'm logging in and logging out of the application, even on the one like infinite time of login, the session token will always be Harsh at the rate 123 only, right? Now, if the session token length is like same always, and if it's a predictable or you can brute force it because it's a short length token, you can perform a session fixation attack over there and simply generate a token and change it to the victim's session token, and you have now access to the victim's account. In this case, it's a persistence access because the session token is always same. There might be some predictable identifiers, say the user ID is like, say 1337 is my attacker's user ID and victim's user ID is 1336, 1335. So it's like incremental by +1 or -1. So you can basically chain it with the IDOR and further perform the attack. Sometimes you can guess the username and email address which are required to perform, say, CSR for IDOR via forget password or via registering an account. So these are the way which you can try to change the vulnerabilities. There might be some security misconfigurations, like a server which is having a default password set. You can always look for those endpoints and see that if there is some application on port 9000 which is having some default password, say admin or admin password. Say there is a server called a Tomcat server is running, and you can use the Tomcat's default credential for the manager interface and perform a remote code execution, and further ultimately you have the complete access of the application server itself. So yeah, a direct request or missing authorization check again comes into the same form of vulnerability. So say there is a endpoint called /admin which enables you to access the admin interface. Now /admin allows you to change or create any user, change any user's information, any user's password or something. Due to missing authorization check, what attacker do is attacker log in with a normal user and forcefully browse to /admin endpoint. And if there is authorization checks missing, the attacker would be able to access this /admin directory, and then further can perform all the changing the user's password or some of the functionality. This will depend upon the application to application that what rights higher privileges users have. You can use a plugin called Auto Repeater or Auto Rise. I usually refer to Auto Rise because it's fairly simple plugin to use. All you need to do is to take the session cookie from one user, say lower user, and navigate the application with the higher privilege user. It will automatically hit the request and repeat each and every request using low user's cookie, and will tell you that if it's bypassable or it's enforced or it's the tool is not sure whether it's bypassable, so that you have to manually check. Okay. Auth misconfiguration is again one of the attack vector which is coming into the picture since I guess say 1 year, where the application uses a single sign-on mechanism, say facebook.com to sign into any application, or say gmail.com. Now, if there is an improper handling of generation of that, how these this login process is happening, attacker can basically perform an attack, say auth CSRF, where the state parameter is missing. So state parameter again works as a CSRF token for this auth based sign up process. If the state parameter is missing, an attacker can simply generate a CSRF POC for these auth and send it to the victim. Now, when the victim will open the POC, the victim's account will be linked to the attacker control account, and now attacker can basically access the application, the victim. So for example, there's an application called test.com which allows a single sign up using facebook.com and missing the state parameter. Attacker can generate a POC for CSR POC for that, send it to the victim user, and now whenever the victim user will open, the victim's test.com account will be linked to the attacker's Facebook account. Now attacker can go to test.com and log in via his Facebook account to the victim's test.com account. So again, auths are not limited to this CSRF attack. There might be some other attack like say auth redirection attack and others. But since we are focusing upon account takeovers, this is one of my favorite way to perform auth based CSRF. Haven't found in any bug bounty program so far, to be honest. But yeah, in some the pen testing engagement, we often find these kind of misconfiguration. Okay. So just it's a time for the case studies. I will be taking 1 second on mute. Just please provide 1 second. Okay, so we will be quickly going over 3 to 4 case studies where we'll be discussing that how I was able to find account takeovers and utilize broken cryptography, cross-site scripting, CSRF, IDORs, reset poisonings, everything into the real life application onto the bug bounty programs themselves. And yeah. Okay, so first we will look at broken cryptography to account takeovers. most of these case studies are already pre-written blogs by me only on the Medium. So if you want to read the complete blog, you can go to my Medium and refer to it. Okay. So there was an application which has this usual password reset flow. You will request a new password. You will receive a password reset link, which will ultimately resets the password. Okay, so this is everywhere we usually see. So while resetting the password, I basically always use two accounts which are somewhere differentiated by the aliases +1 and +2. So I basically was testing this password reset functionality, and I got the password reset link for both of the account 1 and account 2. So if you observe over here, the password reset link for account 1 and account 2, which looks something similar like this. Just give me a second. Okay. Yeah, so if you will look at this password reset link for account 1 over here, the token field, right? So the token field in this one and the reset link 2 has the difference of only 0, 1 and 0, 2. Rest every single character is same. So this thing took my total interest, because now we can assume that there might be some kind of misconfiguration, because how it is possible that for the two different account only +1 and +2 are different. Okay, so basically I calculated how many characters are there in this. So for example, there are 10 characters in this particular email and 10 characters into this particular password reset link. So then I checked what is the number of character into my email address itself, and I found that both are having, say, 10 digits only in the email 1 and email 2. So again, from that it was sure that there is some sort of misconfiguration. I again quickly created two more accounts, and which were like, say, of length 11. Now I went ahead and checked, okay, now let's see that when we will get the password reset link, what will be the results. To again my surprise, the reset link was of 11 characters with only one, that +1 and +2 was changed. So okay, now this was clear that there are some security misconfiguration for sure. I noticed that, see, these are the three characters over here, if you see, which somewhere says that com, because after dot I am writing gmail.com, for example. Okay, so this was the Harsh Bothra +1 at bugcrowdninja.com. So okay, now I know that .com is over here in ZBP. So if we usually go and see, if you are from BTech or engineering or BCA background, you know that the Caesar ciphers involve that we simply change the numbers by, say, I will say that I am changing A by Z. So there is a fixed number of letters which I move the application. So sorry, move the cryptographic code itself. So after a little bit observation and a little bit of this particular, what we say that fiddling around with the application, I found that, let me just quickly erase this thing. Okay. Yeah, so I found that the application was using Caesar cipher, or you can say ROT 13 as the cipher. So this was the formula which I basically reduced, that Caesar cipher or ROT 13 with the reverse of the email address will be giving you the password reset token. So for example, the victim's email is hbothra22@gmail.com. Reverse the email, you will get some string like this. Okay, so this is the, just a second, please. Yeah. So this is the string, this hbothra22@gmail.com, which again somewhere looks like the previous hash in the reverse format, right? Now, encrypt this particular with the key 13 Caesar cipher or ROT 13 simply, you will get this particular hash. Now change this @ to %40, and now if you see that we are getting something into the same format, this ZBP is always same and the same format, right? This is the final example token, which can be used to perform the password reset. All I need to do is to go to this target.com/reset password_token equals to this attacker generated token, and I can now basically reset the password for the user hbothra22@gmail.com. So initially this bug was traced as a P2 bug, and then it was like P1, got into P1 rating, and finally the appreciation received was for P0 because of the complete reduction of the formula and everything, which cleared the team that how to secure it. Second case studies talk about CSRF and client-side validation bypass to account takeover. If you don't know what client-side validation is, so basically giving an idea. So say there is a username field called a field called username, and which is required field. You often see a red color star mark or something. Now, I captured the request in the burp suite and removed the field or the field's value. Say in the username field, I provided Harsh, and now I removed it in the captured request, and now I send the request to the server, and now server process the request, and I can see that in the username field in the UI part there is no username at all, it's blank. But how it is possible for a required field to be blank? Because the validation of the required field is only at the client side, not at the server side. So this is a low security bug, but it can be chained with some other bugs like CSRF to perform some malicious activities, which basically I did in performing an account takeover. Okay, so let's say the target was target.com, and there was an endpoint called edit profile, which had the request like this. The body is like username equals to test, description is equals to again something like some the basic profile description, phone number, and NT-CSRF token. So NT-CSRF token was not weak. Again, they are validating if the token is forged or not. So no luck basically with the NT-CSRF token right now. I changed this post method to this get method and removed this particular NT-CSRF token field and performed the request. Okay, and I was able to successfully perform the request, and the request happened. I can change the any user's now username or the phone number. Now, again, the phone number was not a point of validation to log into the application. It was utilizing the email, and email was not changeable at all. Okay, so now we need to find some other way to perform account takeover, because only changing the username or mobile number is okay. It's again an impact on integrity, but it's not as critical as the account takeover. So there was again a functionality called change password, which was having this current password, new password, and confirm password field, and an NT-CSRF token. So now we know that we can bypass the NT-CSRF token. So what I did was basically I removed this current password field, and it successfully reset the password for me. Okay, so now what I did was I basically chained the chained the two vulnerabilities, the client side validation bypass to remove this current password, and the CSRF to just removing the NT-CSRF token by converting a request from POS to GET. And at the end, we had like a request which was looking like this. All you need to do is to copy the URL and send it to the victim, and once the victim will open the link, its password will be changed. Okay, and now what you can do is you can basically go to victim's email address, use the email address, and now log in to the victim's account. So in this scenario, that often that people ignore such bugs into the bug bounty engagements or the pen testing engagement, saying that okay, what is the use of why a user will go and manually remove the current password field and perform a new password, but what if an attacker can do, right? So always think about the chaining the vulnerabilities, because it always give you edge over others, and the severity always increases when you chain the bug properly. So the next case study is about cross-site scripting to admin session hijacking and performing privilege escalation. Okay, so there was some application which was vulnerable to stored cross-site scripting in the description field of a user's profile. Let's again say the application was target.com. So the usual flow of the application was the admin user can add multiple users with the restricted roles, say user one, say admin, then manager, then say visitor or viewer, like that. When admin create a user, basically it invites a user to join the organization, and a user has to fill all the details while creating an account. So the description field was basically vulnerable to a self-stored accesses, I can say, which was basically reflecting on the admin's panel under people's directory. There was a particular option where an admin can go and check any user's information. And once the user basically create the account, right, the admin also has to approve all the things. So admin anyway has to go to user's profile. And since we have this stored accesses, it will basically pop up at the admin side now. So basically, I reported this as a simple accesses, but I just wanted to perform a real-time accesses for more fun, because I was inspired by one of the recent exam which I gave for the SINAC. So I again noticed the cookies. There was no secure HTTP only flag, so it gave me an idea quickly that now I can create a script on host it on my remote server to steal the cookies. And now I basically modified my stored access payload to be a cookie grabber payload, and it will redirect cookie to a remote server which is controlled by me. So far we have a perfect method to perform session hijacking. I can now log in as an admin user, but again, this session is not persistence in nature. It's like by the time the session is active, I can access the admin user's functionality, right? So I logged into the admin account and navigated to this people's directory again. Sorry, yeah. So uh, I changed my user's permission to be an admin user, right? Now the lower privileged user has the complete admin user, and just for fun, because these were my test account only, I again went ahead and removed the original admin from its account itself. Okay, so now if you see that basically the lower hanging bugs like missing secure and HTTP only flags on cookies to performing a basically a real-time session hijacking to performing a priv escalation, the impact goes to critical again, because there is very less user interaction involved, because admin just has to go and approve the user, which is the usual flow of the application. So always make sure that you are not just reporting cross-site scripting. Always check for the cookies and basically perform a session hijacking at least, so that you know your impact from P1 or from P2 or P3 goes to P1 directly. Okay. Uh, let's talk about IDOR in session cookies to account takeover. This is something which I came across only once in my life, and which it was really a weird bug that developers can do anything. It gave me totally confidence that developers can do anything in the world, right? So log in as a victim user and capture the request with the burp suite, or you can use the cookie editors or any dev tools. In cookies section, there was a parameter called role parameter, which was having a two-digit value called 00. And obviously, it will take interest for anyone who will see that role parameter with a simple value of 00. So just to confirm, I created an admin account and observed that now the role value in cookies is 11. So further, I created a simple user role and permission matrix. I like by user role and permission matrix, basically write down all the users in the application and all the permission each user role has. So for example, there were like 4 user roles: a manager, modifier, admin, and the user, normal user. Now, uh, after that creation of this particular matrix, I observed that the for user it uses 00, for admin it uses 11. So basically, it's a change of binary bits only. 00 says that no permission, it's a limited access user, and 11 says that all permission, it's a full-fledged access to the admin user. Okay, now all I need to do is to change the value in the role parameter from 00 to 11, and now I have the access as an admin user of the application, right? It was a simple pre-escalation, and further, I can basically, there were some functionalities of the application which led to the account takeover itself. Again, the IDOR and password reset to account takeover. So basically, the name should be password reset poisoning attack itself. So there was a password reset page which was vulnerable to host header attack. To give a quick idea what host header attack is, you often see there is a host parameter after this get or post where just let's move to this CSR of one where you will be able to see, I guess. Yeah. So if you can see this particular host target.com, so this is basically the host header in the the request body. Okay. So when as an attacker, I can provide some malicious host, and the 302 redirect is there, which will say that location is now the malicious host. This is basically the host header attack that you can implement, or you can change the host to an arbitrary or attacker controlled host, and the application will now consider the arbitrary host as the actual host. Okay. So usually this attack has no impact, no significant impact, because who is going to do this manually on the victim side, right? But if you can do it on the password reset link with the malicious origin, it holds an impact. Okay. So victim will receive a password reset link with the malicious origin like this: https://malicious underscore target.com slash this reset under slash token, and the token over here. So when you will change the host header to some attacker control, you will receive these kind of spoof link in the victim's email address. Now, there is a logger already set up at the attacker controlled domain, say this malicious target.com. as soon as the victim click on this spoof link to perform a password reset, a lot of victim will be falling prey of the social engineering attacks. Once the victim will do that, the token will be logged to the malicious target.com's logger. Attacker has to just simply use that token, put it over here with this original link, and now the attacker can basically perform the password reset. The token has no expiry in this particular application's case, and thus the attacker can utilize the token as many time as he wants to perform the password reset, right? So these are a few scenarios where basically you can chain the bugs and see that what you can do. uh, Only tip over here is to always look for the low hanging vulnerabilities and try to chain them with the higher vulnerabilities like CSRF, IDORs, cross-site scripting, because you can increase the impact by chaining both of them or like multiple vulnerabilities together, and see that if you can perform actions like account takeovers, if you can or for like broken cryptography checking, always use burp sequencer and check the randomness of the token generated. Try to see if there is a JW token, try to see if you can use non-algorithm attacks. You can, if there is HS256, try to get hold of the public key by directly brute forcing or checking the source code or something, and try to forge a token. So just do not stop at the first vulnerability and be quick to report it. Try to increase the impact and see that how malicious it can be for the application and what attacker can do in the real time. So this sums up my talk upon broken cryptography and account takeover. Hope you enjoyed it. So if you have any questions, you can go ahead
Yeah.
and ask. Yeah.
Yes, Harsh, there are a few on YouTube comments.
Okay.
Rahul is asking difference between IDOR and privilege escalation and AT. I don't know what is AT.
Okay. So see, AT, he means account takeover, I guess. So yeah. So account takeovers basically, as I mentioned, that it's not a vulnerability class itself. It's basically the result of the some existing vulnerability, right? Say IDOR or say priv escalation. Okay. Now the priv escalation is something where you're bypassing the authorization check. It doesn't require you to send a request or response or modify some user ID or something. It can be like you are basically performing a directory brute forcing, okay, to slash admin endpoint, and eventually there was no authorization check in place and you were able to access the slash admin directory. So from a normal user you moved up to the higher user, okay. And again, when we see IDOR, so say there was an application having this vulnerability of IDOR, you can change any user's say username or email address or something. So you are doing it on a vertical level, on a horizontal level, right? So the priv escalation basically comes under the broken authorization checks category, and the IDORs usually come under the broken access controls category.
Okay. The next question, how do you identify a difficult hash?
So see, all hashes do not need to be insecure. So what you can do is you can first go and try to see if there are some of the common hashes. So if there is some base 64, these will be visible directly, right? Say there is a session cookie which is saying that PH session ID or J session ID. Now you know that the JSP or maybe PHP's libraries are used to generate the session token. What you can do is you can go and check on GitHub and something that what all cookie generation methods and libraries PHP or JSP uses, and you can try to see that if there is some existing vulnerability into those libraries, and try to utilize those vulnerabilities to see if you can generate a new token or like that. There is a website called, I guess, the Cyber Chef, which allows you to
Yes.
create and encrypt and decrypt the things based on the recipes. So you can basically try to fiddle across various recipes and try to see if you can decode the hash or get idea of the hash.
Okay. So the next question is clickjacking help you out in account takeover?
So clickjacking may help you in account takeover if it's on some sensitive action, say password change. But again, like clickjacking involve a higher degree of user interaction. So anyway, if you're able to perform clickjacking on any like clickjacking to account takeover, the severity will not be that much great. It by maximum it will go to medium or high itself, right? Because it totally involves upon creating a visually looking page and
Hmm.
relying upon, and these days like a lot of application by default like blocks the clickjacking attack itself. So yeah, it can
Okay.
be used to perform account takeovers, but again, depends like how you are social engineering the victim user in real life.
No, but like in all the bug bounty programs, like clickjacking is not in scope. I have seen a lot
Yeah,
of
yeah.
times.
So they say that if there is sensitive action like say transaction button or say delete account
Okay.
button, then we will consider it. So yeah,
Okay.
some
Okay.
programs say that only like sensitive areas or sensitive actions will be allowed for clickjacking to be accepted.
Okay. Okay. So the next is, how did you check if the token was not expiring with the resetting password once and trying again or something? Or there is another way to check that?
Yeah, so basically use the password reset token twice or thrice because
Ah,
this will give you a simple idea that if the token is expiring or not. Further, like you can go and check the token after 2 days and see that if token is expiring or not, right? So these are the simple method that sometimes you can use and see. So when we do the pen testing engagements, right? So on the day when we capture some this reset tokens and we try to utilize the same token on the day last, so
okay.
it's like usually a 5 to 10 day engagement. So we get a good idea that okay, yeah, token is like we having a very large duration of this long duration of expiring.
Okay. So another question upon the previous one. Can IDOR lead to a horizontal privilege escalation?
Yeah, so basically, if you say when we talk about horizontal priv escalation, these are like from user to user, right? The both user have the
Hmm.
same permission to the application,
Yes.
but
Yes.
the both user cannot access each other's data, right? So if from attacker user, I can impact the integrity of victim user, say I can change the email or I can delete anything or something. So it's basically playing around with the permission of the victim user itself. So yeah,
Hmm.
it's ultimately the horizontal priv escalation itself.
Yeah. The next is like you were talking about security misconfiguration, and you were saying that you should check for default passwords. And also, is there any other thing as well that you check for when you are testing for security misconfiguration?
Yeah. So basically, the security misconfiguration can be anything like a server which is using some older version and might be vulnerable to remote code execution attack, might be vulnerable to a server-side request forgery attack. So security misconfiguration is basically like whatever configuration are made on the server, like it might be server, it might be library that is being used, and there are some known public exploits or some known methods available on the internet to exploit them. You usually check that, but specifically for the account takeover, usually like the default credentials are the thing that you
Ah,
can check.
yes. Okay, okay. I also wanted to ask if any particular burp plugins that you use to do all this kind of stuff. Like,
Yeah, so basically checking for the authorization and the IDOR and priv escalation, I use this auto repeater and this auto rise. Again, auto rise is like really simple. What you need to do is basically log into your victim account, say lower priv account,
mm-hmm.
copy the session cookies, paste it in the author this particular say authorize plugin, enable the authorized plugin, and there's option called check unauthorized, right? So what it will do, it will totally remove the cookie itself and see if a non-logged in user can perform a priv escalation or not, or can perform a authenticate action or not. So then simply log out from your main user and surf the application from a higher user. So just make sure that okay, the bug proxy is on, just make the intercept as off, and when you will navigate throughout the application, it will keep on hitting the request with the unauthenticated, like removing the cookies and the lower users cookies. Now it will give you like responses called bypassed or enforced. So enforced is like it's secure. Bypass is like it might be possible that there is the IDOR. So you can like just have to verify the bypass once. That's it.
Okay. And just like bug bounty kind of question, like
Okay.
I wanted to ask, like on what basis you decide select the targets? Like if you are scrolling through bug crowd or hacker ones, so you just randomly select, or are there any things that you consider while like pen
Okay.
testing? Yeah.
So scope is something which I always go about. I barely like a scope where the sandbox environment is given, because there are a limitation of the attacks, because they will the vendor will say that yeah, I am aware of this is a sandbox environment, I don't want to
Ah,
implement the session cookies with the secure HTTP only flag, right? But
okay.
it happened actually with me, because in one of the scenario I reported a cross-site scripting session hijacking only. Okay. the guy came in and said that we will accept the cross-site scripting as a low bug because the cookies are already secure on the production website. So this is
Okay.
something they fiddle. So I go about something where they say that everything is in scope, all assets, all subsidiaries are in scope, because that's where you can utilize the power of reconnaissance a lot. Because this is
Hmm.
my favorite part. Like there are say everything in scope. A company has a subsidiary, and subsidiary also has some of the subsidiaries, right?
Yeah.
90% people will not look at the subsidiary to subsidiary, like the lowest degree of the company's asset. They will just look for the superficial. And
Hmm.
this is the reason that I came into the top 150 of the bug crowd, looking at the subsidiaries to subsidiaries, because
Okay.
a lot of people just look for the surface. So yeah, the target with a good scope is something that I choose, and less number of out of scope bug. So integrity, if you go like integrity, like say like almost all P4 bugs are out of scope. So I usually like don't hunt there because their scopes are very restricted.
Okay.
Yeah.
Okay, that was a great point. So yeah, there are no more questions now, and thank you for answering them all.
Yeah. Yeah.
Um,
Thank you again so much for like, inviting me for this talk. I guess,
yeah, it was
got it.
great. Means you really explained it very well.
Yeah. Thank you.
Thank you so much, and thank you the audience for joining in. And you were great in questions also. So yeah, then see you in the next one. Till then, bye bye.
Thanks a lot, everyone. Thanks, Harsh.
Thank you, Anand. Thank you, Shreya. Bye, everyone.